In this podcast, it's kind of a hodgepodge of other naming rules for alcohols. We're going to talk about how you name cyclic alcohols, diols, trials, and we're also going to talk about what happens when you have a hydroxyl group acting as a branch rather than the main functional group for a molecule. All right, for cyclic alcohols, it is treated the same way as a cyclic alkane or a cyclic alkene. You're going to add the word cyclo in front of the parent alkane name. So if we had pentane as a cyclic, it would be cyclopentane, but you're going to drop the E and change it to that OL that tells us that there's an alcohol or a hydroxyl group present. So let's do an example. This is the parent chain would be cyclohexane. So I'm going to change the ending. I'm going to drop that E and add an OL. This is cyclohexanol. I do not need to number this because it is always assumed when you have a hydroxyl group that that automatically gets carbon number 1. So I don't have to number the position of that. In our next example, we have two groups present. So remember that the OH is always on carbon number 1. And now I need to determine, am I going to count clockwise or counterclockwise to give that group the lowest number? I'm going to count clockwise, giving it carbon number 2. So this would be 2-methyl cyclo, and this would be pentane, but I'm going to drop the E and add an OL, cyclopentanol. Again, I don't have to state the number that the OH is coming off of because it's always assumed to be on carbon number 1. In this situation, it appears that we have a hydroxy group coming off of a benzene. But you should recognize this right away as being one of those aromatics with a common name you had to have memorized. So whenever you see a benzene ring with an alcohol coming off, it is automatically phenol. If this had other groups coming off of it, remember that this carbon would still be carbon number 1, and you'd number the other groups accordingly. All right, sometimes our compounds are going to have multiple hydroxyl groups, and in that case we would consider them, if they have 2 hydroxyl groups, to be a diol, meaning 2 alcohols, or they can be a triol, which has 3 hydroxyl groups. So let's see how to name these guys. All right, we always start with our parent chain, and that in this case is going to be ethane. We do need to, when there's more than one hydroxyl group, we do need to list the position of those. So this is 1, 2, ethane, diol. So we are referencing that there are 2 alcohols in this. Try the next example without me. Pause me, check in, see if you get it right. This next example has hydroxyl groups in the 1, 3 position. So we are going to start by labeling the position of those. This is a cyclohexane. We're going to drop that E. Actually, we're going to keep the E and call it a cyclohexane diol. So again, this di is telling us that we have 2 hydroxyl groups, and of course, right before we need to label the position of those. All right, sometimes we can have more than one functional group present on a molecule. If a compound has a double bond and a hydroxyl, your hydroxyl is going to take precedence over the double and triple bonds, but you're still going to have to state the presence of both of those, and these are going to be pretty rare in this class. So we're going to start with giving the OH group precedence. That has a higher priority, so we're going to have to start counting right to left, and this will help us to number. So we're going to first address that alkene. So we have a double bond on position number 2 in a 4-carbon alkene. So this is butene. We're going to drop the E on this. We're going to give it a dash, and we're going to state the position of the OH group. So it's on carbon number 1, and then we end the word with an OL. So this is going to be very rare for you to see, but I want you to see how much more complex it can look if you have 2 functional groups. And we don't deal a lot with this in Intro to Organic Chemistry as much as you would in, say, a year-long organic chemistry, but you may see it from time to time. I strongly recommend that you pause, try this next problem, and then check in with me. All right, again, we are going to start counting to give that alcohol priority. We want to give it the lowest number of carbon possible. It looks like we have a similar situation. We have a 4-carbon molecule, and the double bond this time is in carbon 3. So this is 3 butane, dropping the E, and we're going to say what position that OH group is on. It's on 1 OL. So we've taken care of the alkene, and I apologize, I put an A there. Let's get that E. Boom. All right, so in this situation, 3-butene 1-ol is the parent chain, but don't forget that we have a branch, so that's going to go in the front. This is 2-methyl 3-butene 1-ol. Later on the semester, you're going to see hydroxyls that are acting as a branch, and this has to do with the priority of the functional group. So some molecules have very low priority, and some have higher priority. The higher priority functional group gets to be the parent name, and so it's going to be the suffix that you wind up naming it for, and you'll name the other functional group as a branch. So OHs or hydroxyls can also be a branch. If you have another functional group present with a higher priority, and you don't have this in your book, we don't talk a lot about this, but I just want to show you what I mean by high and low priority. Alcohol is about middle of the road for priority. If we had, and we saw on the last slide, an alkene or a double bond also present, alkenes are lower priority. So because of that, on the last slide, we named the molecule as being an alcohol, and we addressed the alkene as being a branch on there. Now say we had an amide and an alcohol, we would name it as being an amide, and we would reference wherever that hydroxyl group is as being a branch. So we would say 1-hydroxy, whatever else the rest of the name is. This you're not going to see very often. Just want it to be on your radar that in all other organic chemistries, we do have multiple functional groups present, and so there is an order of operations for what you name and what becomes a branch of that name.